Hi guys, we're 1293 RoboKings, Aurum this season we're called, and we're just going to give a presentation, thanks to Equilibrium.exe as part of the balance workshops about optimizing a robot for performance. Yeah.
I'm Tinko, and this is Tinven, by the way.
So when you optimize a design, basically optimizing it's a large part of your performance in FTC. So there's a lot to be done with optimizing it. So that looks like basically trying to get extra speed, trying to get extra consistency, reliability out of your design, which means basically iterating on your robot. So all teams will do this, and there's a couple tips that we have to make this process more efficient and more effective. So what we like to do is we start in CAD, which a lot of teams do nowadays. And after we design the robot, we'll like to do a really quick run through and a build of the first CAD design with cheaper materials. So for example, instead of using aluminium, we'll use MDF or we'll use wood or something like that. So that's to basically see if there's any major flaws in the robot design. So if there's any holes misplaced, CAD designers, they're not always perfect and they mess things up. So that's always important to do, I think. And then obviously quickly test the subsystems, but don't spend too much time trying to perfect, a robot with cheaper materials, especially if some of the plates need to be aluminium. So after we do that, we'll move on to a more optimal material, for example, aluminium. So that has more strength, better strength to weight ratio, et cetera, which is better for robot play, obviously. And then we'll actually begin our iterating process from our first competition. So obviously we might need aluminium parts for our first competition for our robot to work. So that process, when we're optimizing and iterating, we try and do a lot of testing and then look for the main limiting factor in performance. So this could be speed of a certain mechanism. This could be stringing, for example, or wiring or consistency. Basically whatever's holding you back from doing better than last time. So obviously from there, you can either free build a solution or you have to go back to CAD. It depends on your situation. But when you try and design a solution, we try and consider basically all options, all possibilities for, all right, so what will this new solution bring that the other one didn't? And then you should also consider timeline, materials, and then the more analysis and the more thinking you can do about the solution, usually the less iterations you have to do and more time you save. And then once you implement that, you do the same thing again to try and squeeze that last little bit of performance. So that process of optimizing is how you make your robot better. So we'll go through an example for last season's robot, which is for our outtake arm and our outtake core. So basically you can see we started with our initial CAD and then it changed a little bit in CAD before we'd actually done any testing. So we changed it a bit based on other mechanisms. So we've done testing on other mechanisms and we're like, all right, the transfer point needs to be down a bit, to the left a bit, whatever. And then we went through and you can see on the right, we tried to build it in a cheaper material. So you can see MDF, we used 3mm MDF and then zip ties, and then we didn't do our wiring super properly. We just tried to make it as quick as possible, do some quick testing, and we found, all right, so there's clearly some structural weaknesses in this this component. So we need to make it stronger. So obviously we're trying to reduce weight as well, but we'll consider, all right, we're going to try and add some more structural cross bracing here. And really try and think of a considered solution. And then we'll go back to CAD, change it all. So in this example, we actually changed our claw. We changed the way our brace was being held. We changed our arm design from COTS beams to a custom plate. And we changed the transfer point like I mentioned before. So it's quite a bit of changes. This process that you're seeing probably happened through like 3 or 4 more iterations. And then obviously you test it, and then until you're happy with it, you build it and then run it on your final robot. Yeah. And even then there are still optimizations to be had to further improve performance.
So another thing that you really have to do when you're building and testing your robot is to reduce failure points as much as possible.
Also in the design phase.
Yeah. So even if you do everything right, something always can and something always will go wrong. So in Worlds, we disconnected for an entire match, and before our first match last season, our robot just wasn't working at all due to some static interference on our RS485 cable. Basically, the less failure points you have, the easier it will be to diagnose issues and fix them quickly in that 7-minute period in between matches.
So what failure points usually look like for robots is if you have an intake jam, for example, or if you're doing a transfer in some games, that is usually a common failure point, because if you think about it, the game element could get jammed or stuck in the robot. So a lot of teams account for this in the design. For example, like an angled ramp, or a lot of testing, a lot of iterating to basically make sure that you can't be dead in the water. Another good example for this was the barriers on Freight Frenzy. So some teams could get stuck on the barriers, and they'll be out for the whole match because they wouldn't be able to move. They'd be stuck in that little triangle bit. An easy optimization for that was just reevaluating a drive base, maybe increasing the clearance or adding a plate so that you couldn't balance on it or get stuck on it. But yeah, that's one example.
One of the main things that we do to reduce failure points in a game is we have a manual reset mode. So basically, if you have more than the legal amount of freight in your robot, and you can't get it out, you're obviously out for the rest of the game. You can't do any scoring. So we always have a manual reset mode coded in. So I'll show you what that looks like here, and then I'll explain what it is. So it looks very quick, but we've just reset all of our servo positions after our autonomous here. So you need a manual reset mode if something goes wrong in auto, or if you get bumped and a cone falls in, or like a pixel falls into your robot. A manual reset mode is we just have our secondary driver have a button where they can press, where then they can manually move all the slides in and click out of it. So once you click out of it, it'll reset all of your like servo positions and encoder positions so that your positions aren't off and your transfer and everything will still be working.
Yeah. This is usually to reset encoders, because I know some teams have a lot of issues with after autonomous, if your motor's not in the right place and you're using drive encoders, then it'll mess with your subsystems. But you can also, if you don't want to do this because you think it takes up too much time, then you can code this into your sequences, like for your actual Teleo code in a more optimized way.
For a manual reset, there are a lot of different situations in which you can use it. So it's really important that the drivers use drill so they can practice manual reset in all scenarios. Another thing that we do to optimize is a whole bunch of free build solutions. So obviously you do as much as you can in CAD, but there's always more that you can do. So we like to use a lot of polycarb mostly to help fix this on our robot. So for example, adding covers over our rev hubs so our wiring can't get caught or damaged. We have 0.8 mil polycarb flaps over loops of our wiring, so it will never get entangled or move out of the designated space that it has. And we also have polycarb parts all throughout our robot, just bent, custom bent, so we can never get freight stuck in our robot. We manufacture our polycarb parts just by cutting them up with a handsaw, heating them up with a heat gun, and bending them over any flat surface. So they're really easy to manufacture, and you can prototype them really quickly because of that.
For teams that like want to use something else or have a lot of COTS parts lying around, obviously the same goes for Go Builder parts or Actibotics parts, whatever you use. So you can just add beams here and there, whatever really works to fix your problem sometimes.
Other free build solutions that we have done is basically just surgical tubing. So we use that a lot on our robot as counter springing. We tend to go with pretty complicated designs to meet our design goals. So there's always going to be restrictions with weight and everything. For example, on our outtake last year, our servo that controlled our linear rail on the outtake actually wouldn't lift it because of the position of the intake, the linkage. So what we did was we just attached surgical tubing from the top of the linear rail down to the servo mounted on it. And it just helped to give it that extra bit of lift that it needed for the servo to work. And another bonus was it helped our wiring be a lot neater. This isn't really optimizing your robot, but before you, if you guys have if your team has a really set routine, that'll also help you to make sure that you're in the right flow before a match. So before a match, we like to clean all of our robot with dryer sheets to reduce the chances of ESD and ground it properly. And then when you go onto the match, onto the field, everyone should have a specific task. So one person should be setting up the controllers, one person should be selecting the right autonomous, one person should be designated as the person to go to the question box after the match if there are any questions or everything like that. If you have a practice routine, you're less likely to mess up and get the penalties from stepping off the stage at Worlds or
touching the driver, the controller.
Randomization.
And it just helps build up that consistency that you need across competition day as well.
Okay, so wiring is a really, really important thing. I think a lot of people overlook it. Wiring can really be such a limiting factor on your robot. If your wiring isn't good or if it's messy or in the way, it'll obviously limit your performance a lot. So if your wiring is done well and it's neat and it's modular, then you'll have a lot of an easier time diagnosing issues in that short 7-minute period. And it'll also be a lot easier to do just regular maintenance on your robot. So there are a couple of things to take note of that are really important when you're doing wiring. The first is to avoid as many kinks in your wire as possible. So always try and do turns or slight bends rather than twists. So as you can see on this image on the right here on our intake, we have like a lot of degrees of freedom, but we have everything, nothing, the wire doesn't actually bend fully, bends flat. The furthest the wire bends is like this much, so that there's no stress on the wire inside. And we actually only have 2 connection points on our robot. We have a connection point from the servo where we wrap the servo wire around the servo until it lies flat. And then we have custom wiring all the way to another connection point at the end near the turret on our robot. So we found this to be really useful because if one of our servos didn't work, we knew exactly where to check. There was no chance that it would be in the middle of those connections.
Yeah. So Tinker was talking about servo wiring, but also power wiring is something that it's responsible for a lot of disconnects that teams see. So the Tamaya connectors are pretty bad as well. So we switched all of them out to power poles, which we'll talk about more later.
So we have some more examples of our wiring here. It's really important to take wiring into consideration when you can. Say, for example, if you've designed a turret, that's really easy to take off. Like you can take the turret plate off with 8 screws. That's a really modular design. But if there's no place for your wires to go other than right over your turret, there's no point of having a modular turret. It just doesn't work out. So having a lot of space around your rev hubs and trying to have designated paths along your robot for wiring is always optimal.
We like to have, obviously in our last year's design, we didn't do this quite well, but if you can have the rev hubs closer together, that means that the connecting cables, for example, that RS485 and also the power cables, they can be shorter. And it means that if you need to replace one of them, it's less of a task. So if you do mount the rev hubs on opposite sides, for example, like we did last season, then we think something like a bridging structural plate or somewhere where you can run the wires more directly from one hub to the other. Obviously, if you mount the rev hubs close together, then you don't need this.
A bridging plate's also really good because it's added structural support. As you can see on this image on the left here, this is our outtake wiring. So we've used a lot of loops, basically. We had a lot of moving parts. We had linkages. So what we do for our slides wiring is we actually just connect the wire, we do it in a loop, and then we extend the slides up so that it's always twisted so that when the slides come in, it'll be in a loop as much as possible. This means that our wires didn't have to bend as much, and it just makes wiring a lot cleaner. Custom wiring is a thing that you can do on your robot if you have time. We personally like to do it. There are a couple of really important things. If you're doing custom wiring, you should never, ever, ever solder your wires because they will
solder sometimes.
No, try and avoid soldering where possible because the solder will eventually crack and break. And then even though the solder may look perfectly fine from the outside, the connections will just be gone and it will cause you a whole ton of issues that you really don't want to get into.
It'll look like intermittent disconnects. So you'll see a server that will disconnect randomly and you won't know why, and then it'll reconnect.
So it's pretty easy to do custom wiring. You can get a whole bunch of 0.1 inch crimp connectors from online stores. I think GoBuilder sells some. No, GoBuilder sells wire. You can get them from Amazon, and you can get crimp connectors, and they're just the 3-pin crimp connectors that you can see on the top right. And you can use them to make custom servo wires. As for the actual length of wire, you can buy pre-twisted 25 gauge, 22 gauge, which is the required gauge for wiring.
We wouldn't recommend you go above.
You should not go above 22 gauge. 22 gauge is probably the minimum you should go.
Yeah, just because the resistance in the wire, especially if you're using GoBuilder servos, it causes the servos to have a bit of lag, which is no good, obviously.
So if you do have custom crimp connectors for your servo wires, and the wire, you can just make the wire as long as you need. So if your slides require 2 foot of wire extension, then you'll only have a connection at the top and at the bottom of your slides, which is really good for modularity.
Yeah, and you don't need to loop the wire around itself, which can cause more issues in the future, possibly.
Crimps are always really good, especially with servo wires, because you can use clips that make sure that the servo wires physically can't come apart. You can buy them on Rev. And like Kinzan was saying before, if you have the old Tamiya connections, you should probably switch them out to PowerPole, because the circle pins over time and over use will start to expand and they'll just slip. So you'll have a lot of disconnections.
Yeah, if you are using the Rev batteries, the JT30, I think, you can fix the slipping using a knife and then pronging the middle insert so it will expand outwards. Obviously, probably look at this before you do it, but yeah, those crimp connectors are also pretty good.
PowerPole connectors are probably
So we've gone over optimization of your general robot, and then obviously the wiring, which is a large part of optimization. But once you have the robot, once you have the actual robot working, then driving is also a huge part of your team success. Because obviously it's in robot play, it's a 4v4. That's that's essentially what FTC is all about. So you can obviously improve a lot there. So with driving, we basically try and build driver skill through repetition. That's basically the simplest way of putting it. The more tests, the more cycles, the more intaking, the more depositing your driver goes through, then the better he'll do, and the more muscle memory he'll build up over that time. So with driving, we like to aim for a more smooth approach rather than a jerky approach. So we see a lot of new teams and rookie teams bumping and jerking the joysticks, it works. But if you can really utilize the analog control of the joystick to, fine-tunely set the powers to the robot, we think it's better. The main reason is because if you are running a lower ratio or you're lighter weight and you want to go faster to increase the cycle time, then those jerky movements will add to the uncontrollability of your robot. So there's an element really most years of you can, for example, knock something and then all your points will be gone. So this year it's obviously the backdrop. Last year it was a pole. You knocked a pole over, then you're screwed, or the stack. And year before that you could move the hubs. And so if you are having a lot of jerky movements, then it's a lot easier to hit things like that and mess up. Whereas if you have more control over your joysticks, you should be able to drive faster with more control. So, and also building up speed is important. So what some teams do is they limit their power at the start of the season and then slowly, gradually work their way up once they have control of that power.
Another thing that you should do with your driver team is develop driver cohesion. So obviously in a general drive team, you'll have your main driver, your secondary driver, your coach, and your human player. So the way that we do it is our strategy, or our coach will say something and our main driver will listen to the coach, and then our secondary driver will only listen to the first driver. The secondary driver won't listen to what the coach is saying at all. So the main driver has final say, and the secondary driver will try and read the robot first before communication. So we try and do, when we're doing driver practice leading up to comps, we try and do driver practice silently. So the secondary driver should be able to understand the robot and have enough practice to know where to go just based on the movement of the robot. That means that when you are in competition and you do add in communication, that you have the extra layer of cohesion and you just work really, really well together.
Yeah. When you're optimizing during drive practice, a lot of teams, what they do is they basically have drive practice sessions and they just drive the robot until they see an issue. So for example, something gets jammed or the deposit's not good or they want to change a sequence. That usually is a large part the software team's job. So changing a sequence, changing timings to speed it up. We think that the drivers should work as closely as possible with the software team. Like sometimes there's a bit of confusion to what the driver actually wants and then what the coder will implement. So having them work as close as possible will save a lot of time in the long run. And usually the driver knows what they want. So that's also good. Dealing with pressure is another really important thing that when it comes to driving. So in competition, in elimination matches, in qualification matches, maybe you have a really important match. Sometimes it can get pretty stressful. So yeah, and there's a lot of pressure to perform. So you can prepare for that, and which is part of optimizing your robot. Basically, what that looks like is a lot of practice. So practice under high stress conditions, whether it's time matches rather than just aimlessly cycling, whether you're aiming to beat someone, be a personal best, or be a player that's playing against you, or beat another robot. We like to have as intense of a session as possible, if that makes sense.
Another thing that we do is we have really, really loud, really, really catchy music to imitate the noise of the crowd. And maybe there are two matches going at once and you'll hear an endgame timer go off for a different match, just so that you can be fully focused on your own match if you're used to already tuning stuff out.
Yeah, so that helps a lot. And then also, like Tinker was saying before, sometimes you can't hear things with communication. So that's why we like to practice silence sometimes. So that also helps with that. So I covered this a little bit briefly before, but with the jerky movements and the high speeds. But what driving is it's basically the more driving you do at the start, the more rapid increase in your drive skill. But even if you have got muscle memory for the cycles and the intake, doing drive practice will still help your team a lot in our experience, even though you might not be able to see it and it might not be as apparent in your driving. So for example, for Worlds, leading up to Worlds, we thought we'd done a lot of drive practice. But then at APOC, after doing more drive practice, we noticed that we were significantly better at scoring fast and also reacting to a bunch of different situations as well.
Last year, the day before we flew out for Worlds, we filmed our robot reveal video and we did a solo max. So we finished the solo max with not even half a second to spare. But after we came back from Worlds, we did it again after all the practice that we did with teams leading up to Worlds. And we actually did a solo max with 30 seconds to spare. So even though it doesn't feel like you're getting a lot better, if you compare your stats and actually log in your stats, which is something that you should do, you'll see that you do have a significant improvement on your robot just from that.
Another good point, a lot of teams do, a lot of high-level teams do, they actually do log their stats, like I think I was talking about. So whether that's through Excel, if you score your matches, you can really see that optimization kicking in and helping your performance. You can also do the same thing with auto as well. So looking at your average cycle time, looking at your average points, consistency as well. That's another great way to optimize.
So here we have a video of one of the intense driver practices that we try and do. So basically, the best way to improve is if you're always losing. So last year we had one of our team members, our German exchange student, Mika. Hi, Mika. Practice against us, acting as two robots. So Mika would always place the cones faster than we could. So we were always constantly losing against him. And this gave us an opportunity to try out different strategies, see what worked best. And also, you perform the best under stress. You improve the most under stress. So I'll just give you an example of what that looks like here.
This was leading up to Worlds, I think.
So it's kind of tricky.
So basically, you can see Mika placing the cones
significantly faster than
a human robot could. So coming towards the end, optimizing code is another way you can optimize your performance as well. So what optimizing code looks like, it's basically adding functionality. So whether that's, I'll give you an example from last season, we wanted to score the beacon and the cone at the same time, one after another. So that was an optimization we made. But to do that, we had to code in a specific sequence that did that when we pressed a button for endgame. So, and then also obviously a large part of optimizing your robot performance and speed especially, and consistency, is modifying the timings or the sensor inputs. So you have a sensor to change states for a specific sequence, modifying that, and then tuning what actions come after one another at what times. That's a great way, really through trial and error, that you can get better. Increasing automation for teleop. So this is it's pretty easy to, once you've got the code, go, all right, this works. We're not going to change it. But if you can increase the automation, it really does take a lot of pressure off the drivers to, think about what buttons they have to press. And it allows the muscle memory to build up a lot easier. So yeah, the less buttons you have to press to score, the better. But also listen to the drivers. So it might be intuitive to press more buttons sometimes.
Last year, we only had to press 3 buttons across the 2 drivers to score a cone. So
yeah. So intake, change the heights, and then drop. And then lastly, where it comes to actually optimizing your software, it's all about increasing the efficiency of your code. So that is basically cleaning up your code structure to make it a lot easier to edit in future seasons, and then also reducing the loop times. So reducing your loop times will reduce how fast it iterates through the code, which will increase the performance of, for example, control loops like PIDs, et cetera, et cetera. Yeah, so we actually had a lot of issues with loop times coming up to Worlds last season, which were a lot of it was silly mistakes. For example, double reading or double writing specific hardware devices.
Not putting all of our sensors onto the same platform.
Yeah. We forgot to stop streaming after Autonomous finished, so still streaming Italia. That was obviously not good. But once you clean out all those things, your control loops should be better. Yeah, which helps with consistency as well. And then also getting the structure right at the beginning of the season. So while CAD is going, if your software team can actually set up a nice structure that's easy to edit if you make any design changes, and it's also easy to go through, increase the loop speed, add additional functionality, then that will save time in the long run as well. So going back to dry practice, when we look for teams, when we're scouting, what we look for is, in the drivers partly, is their ability to think mid-match, because obviously it's a 2v2, unexpected things can and do happen. So if a drive team can react to a difficult scenario, then it's always good. So that could look like defense. So I know a lot of teams get shut down pretty easily and their drivers don't really know what to do under defense. Or it's just someone getting out of their way to mess you up when you're trying to score, something like that. So if you can practice that beforehand in your drive practice sessions, that will also be good. And it'll help you, since you're constantly getting exposed to things that you don't know, it'll help you in a match. If there's something that you haven't practiced, you can respond to that. Yeah, for example, a cone, even like a cone getting stuck in your robot. So even your own robot not working properly. If you can figure out, all right, I need to wriggle the robot this way, I need to ram into the wall, something like that. Reacting like that in a situation is also good. So lastly, we're going to finish it off with center stage, because that's the season. Obviously, we're all working hard trying to make a good robot. There's definitely things that can be applied to center stage. So since a large part of this game is cycle times, a lot of optimizing this season will probably look like reducing weight, which will increase your speed. It also depends on your, aim of the season. If you want to be super fast and light, then that will be reducing weight, which will be a large thing. And then obviously optimizing power draw. So that's another thing we found last season that was pretty important. If you had multiple mechanisms running simultaneously, which is always the best if you want speed, then you need to optimize the ratios of your slides, for example, whatever you're using, arms, because if you draw too much power, then they won't be operating at their full speed. So last season, we actually increased the gear ratio of our slides and intake extension because they were running too fast and it was drawing too much power. And that actually made them run faster in the end. And also this season, we think working with an alliance partner on the backdrop will be interesting. So if you can optimize your autonomous and teleop so you can score with a partner, because obviously autos might be shared. If both robots are going for the stacks, then it's going to be pretty interesting to see how we can time and deposit that. So if you can optimize your design for that, that would also be good, we think.
Thank you so much for listening. Please feel free to ask any questions.
Okay, so the first question we got was from Civ in chat. They asked, what are some driver enhancements that you found were most consistently used throughout the seasons?
I would say probably the silent driver practice, and driving against someone who was always beating us was probably what improved our driving the most. Knowing, like, having that communication between the main and the secondary driver is really important, and yeah, it's definitely, it works.
On the coding side, I think the manual reset has really helped us this season as well. Like, there's a lot of times that without that we would have been completely out for a match. So, for example, a cone has been dropped in our robot, and with our normal sequences, we literally wouldn't have been able to do anything. Or, for example, our slides get caught at a pole, and then they don't fully come in after autonomous ends. Therefore, our encoder position is reset, and it's incorrect, basically.
I think at Wilds we used our manual reset every second match or something like that.
Yeah, and we've done a lot of practice with it so that it was fast enough so that you couldn't even really notice it sometimes. Like
in the video that we changed.
Yeah, it was as quick as basically pressing a button, full powering the slides back in, so everything was all nice and reset, and then we're good to go. We
aim to have manual reset in under a second.
Yeah, I'm actually curious about that. So a lot of people do manual reset in different ways. So I know last year we just like ran the slides at full power. How do you guys do it? Like, do you run the slides for like a second, or do you just like run it at full power until like a sensor triggers or something?
So our secondary driver actually does manual reset. Last year we had turret intake slides and outtake slides. So our secondary driver pressed a joystick on the controller, which put it into a different manual reset mode. So we could use the joysticks to manually move the position of the slides in and out and move the turret until it was back to the correct angle. And then when we clicked out of manual reset, all the servos would go back to their default position as well as the encoders being reset.
Yeah, so you could actually, it wasn't like set power for a number of seconds. It was set power to whatever the joystick input was. So if the turret wasn't centered, we'd have to physically align it by eye, basically, with the joysticks.
Hence the need for a lot of practice.
Yeah, that makes sense. Okay. So Mohammed asked in chat, what do you think is the maximum amount of cycles for pixels during driver control period this season?
So there's 60 pixels in the wing, outside the wing, that you can score, plus the stacks. So there's 15 pixels in the stack for your side and then the opponent's side. So assuming you score all your stacks in auto, which is obviously really, really best case scenario, and then you score all 15 for the other, that's 30 plus 60, which is 90. So you can theoretically be cycling all of the pixels on the backdrop. It'll obviously be really hard. I think we calculated you have to be under 4 seconds cycle time from the wing to the backdrop to score all the pixels in time. And then that's also not to mention, your opposing alliances stacks. But we think at high levels that all the backdrop will be pretty full, basically.
Yeah, I definitely agree with that. Okay. Breaking Cat asks, do you guys have the option for manual control on all servos and motors on your robot, or just like some of them, I guess?
We just have the manual reset on all of our motors, and then when we click out of the manual reset mode, all of the servos will reset back to position. So
yeah, it is a bit of like fine tuning depending on how many degrees of freedom you have. For example, when we entered reset mode, we'd have to manual reset mode. Last season, we'd have to start a sequence that basically raised the outtake linear rail and then put the arm over, because if they all went back at the same time, then we'd get a jam. So
it's not the point of manual reset.
Which is not the point of manual reset. So yes, servos are often harder to control with power than arms because you have them in dot set position mode, or you can't really change it to continuous rotation mode without doing like some funky things like you can control it with when it's in set position mode, but it's just more difficult, and sometimes you just don't need to do that.
Okay. Josh Likes Rice asks, roughly how much time did you guys dedicate to driver practice compared to actually building and testing the robot itself?
Well, building and testing the robot is kind of drive practice in some sense. We did a lot of drive practice.
Basically, last season for our rebuild design standstill, we finished building 2 weeks.
More than that, like a month.
It was not a month, like 3 weeks out from Worlds. But we did have to redo the wiring like 7 times and replace the turret, all of that. So general maintenance. But after that, we would spend time coding because we had to code all of our orders, but every single other spare minute was done on driver practice. The driver practice led to us finding a lot of issues, which meant that we practically had to go back and do a full rebuild.
Yeah. About as much
time, but
probably more time than driving was actually spent on tuning the autos as well. So I would, even more time than drive practice. But leading up to Worlds, there were days where we just spend like full days just doing drive practice, like 12-hour days. Or that's all we do: drive practice.
We tried to get 100 hours of drive practice in on our robot before we went to Worlds.
And we've definitely gotten more than that. Especially preparing for AVOC as well. Yeah.
Okay. If anyone has any questions, put them in the chat. But I have a couple myself. So last year, you guys did a major redesign of your entire bot. So you guys built a whole new robot with like a different design, although like some things that they carried over. Walk me through the thought process in doing that. What was the reason why you guys decided to do a full redesign?
Well, the reason we did a redesign was because we wanted to do as well as possible. We wanted to win Worlds. And with our current bot, we had too many limitations. The goal of our redesign was that we'd never, ever be limited by the hardware of our robot. So it would always be code or our own drivers who
needed improvement. So basically, if you remember our first version of our robot, it was a turret crane design where we still had active intakes, but it would spin the cone in and we'd have to lift up, turn, and then extend. We could also change the pitch of the horizontal extension on the slides. So it was a good design. It could do 1+5, potentially 1+7 in auto. And then it could score all the cones. And it was struggling a bit to score all the cones plus the stack. So it was struggling quite a bit to do a max tele-op. But we basically changed our design goals from the start of the season. So at the start of the season, we weren't aiming for 1+10. We just wanted a consistent 1+5 with minimal turning on autonomous. So the arms doing most of the work, and then obviously to increase consistency, and then fast tele-op cycle speeds. But we saw teams really effectively using intake extension for autonomous, which was a really great strategy, obviously. And then we also saw some benefits in tele-op as well. So because fighting over the junctions on their side of the field were super important, that intake extension would mean you had to drive less. And it also meant that as soon as you deposited, you would have less to drive back. So we basically changed up designs, and intake extension really was the only way we could meet all of our new designs. So it was hard, but I don't think without intake extension, you could do a 1+10, like physically.
We didn't get a 1+10.
Yeah. But, and then also some tele-op things like descoring and stuff. We wanted to do that with intake extension as well. And we also, looking at the first robot, the cycle speed was limited by basically how fast the turret could turn as well. And if you ran too high of a ratio, then you risk power draw, and then you also risk a bunch of rotational momentum as well, which is worse for the stability of your scoring mechanism. So a pass-through design was just, I guess, better in that regard as well.
Last year, leading up to Worlds, we knew that sometimes you can't always rely on your alliance partner in a match. So if you wanted to place in a top seed, then you had to be able to do everything. So that was probably another one of our goals, which led to a very complicated robot. But yeah, basically be able to do everything by ourselves was one of our goals.
Yeah, we wanted to basically just be able to do everything. We also, as a backup plan, because obviously redesigning your robot is quite risky. Even if you have a lot of time, it's still risky. We actually iterated on our first robot, our turret crane design, quite a lot since our national competition. So I think we did a quick rebuild, and then we did a full rebuild in aluminium. We changed quite a lot. So we added a brace. We changed from 2 intake motors to 1 intake motor to reduce weight. We changed the packaging of components a bit. We added odometry. We changed the gear ratio of our turret to make it faster for cycle times, which actually did help. We were cycling quite a lot faster on the updated version of our first robot. Yeah, and then we also tried to reduce space around the intake so that it would have to raise the cone up less before it could turn, which would also decrease cycle times as well.
Okay. Another question Mohammed asked in chat is, what are some ways you think that like you can increase the amount of cycles inside of a match?
So every year, increasing cycle times basically is the more mechanisms that you can have moving simultaneously or at the same time, the better. So, for example, if you're driving and extending an intake slides, that will increase your cycle time. Or if you have less movement to drive, but you can still drive, and then a slides mechanism can do most of the work, that also increases your cycle time. And then there's the more specific, less like overarching type things. For example, how fast you run your intake ratio, how far the pixels have to travel up your intake ramp into your chute, hopper, claw, whatever you're doing. If you can decrease that, that means obviously your intake's going to be faster. And then, for example, dropping 2 pixels at once compared to dropping 1 pixel after another. That's a small thing that will limit your cycle time. Yeah, so it's basically big overarching things and then small refinements. And also drivetrain ratio as well is usually important.
And then wait.
All right, another question. Josh Likes Rice asked in chat, what tips do you have for prototyping early on in the season?
We should do more prototyping than we do.
We do a lot of prototyping in CAD, I guess, but
yeah, we've done some prototyping this season, but I think we should probably do more. Basically, with prototyping, you want to build whatever you're doing as quickly as possible. So fail quickly is what a lot of teams say, but that means
using 2 screws to mount stuff instead of 4.
Yeah.
Using a cheap light material such as MDF. Your wiring doesn't have to be custom. It doesn't have to have wire casing. It's just everything done as quickly as possible.
All you need to do is get bare minimum of what you want to test. Does this claw work? Yes or no, basically. And then what is the limiting factor in this that I can see to make an improved solution, basically?
For us, we were testing our intake, and instead of actually mounting everything, we just had 3 different people hold all of the parts roughly in place, and then we put pixels up it. And it didn't give us the best performance, but it gave us the idea that we needed.
Yeah, yes.
Okay. Breaking Cat asked in chat, do you think having the ability to go under the stage door is important this season?
Short answer, yes. I think a lot of teams we'll see will be able to go under, will fit under 12 inches, basically. It is a challenge for the hang. You have to hang at the end, obviously. It is a challenge to package all that in, but especially with the rules regarding the stage door. So if you're traveling from the plane side towards the backdrop, then you actually get priority over if you're traveling from the backdrop to the wings. So if you can't go under the stage door, you miss an opportunity to kind of slow your opponent down if they're trying to go the other way and you want to get through. So I think a lot of robots we'll see will be under 12 inches.
Okay. If anyone has any more questions, feel free to ask them in chat. So your robot is super customized. I'm interested in like how you manufacture it all. Is it all in-house? I know some teams like outsource some of it to like Senketsen or Fabworks. And if so, if it's in-house, what do you use for manufacturing? Like a CNC, drill press?
Okay, so we use a variety of things for manufacturing. Recently, for our recent Worlds rebuild, we cold emailed an aluminium company, and we asked if they would sponsor us by giving us free laser cut aluminium plates. And we bought them a crate of beer, and they actually said yes. So we did manage to outsource our laser cutting of our aluminium plates, which is really good because at our school we have a plasma cutter, so we can laser cut, but it won't be accurate at all, and we'll have holes in the plates, and we'll have to do a lot of manufacturing. So we laser cut our aluminium plates, and then for everything else, our school kind of has a workshop, but it's mostly just
A drill press.
We don't have a drill press. We recently got a drill, but we kind of just
We
used a Dremel and a drill bit to drill any holes that we needed.
Yeah.
We went through a lot of Dremels.
Our school manufacturing block also has a laser cutter, a CO2 laser cutter. So that's which is really nice to cut MDF plates, because we can cut, plates for a whole robot in like half an hour, which is awesome. So that speeds up the prototyping. And
then for any free build fixes, like if we need to move a hole or cut some poly, we'll just use a Stanley knife, a scalpel, and pre-build it.
Yeah. Heat gun for
polycarb. Heat gun bent over our kitchen sink for our polycarb. It's not the most elegant manufacturing, but it can be done by anyone, and if it works, then it works.
Okay. What was the biggest challenge you faced last year?
Wiring. So last year our robot had something ridiculous, like 14 degrees of freedom. So the wiring, that was a massive challenge. We actually made some really stupid mistakes with our wiring last year. Shout out to wiring our entire robot in 25 gauge wire, which is still an FTC legal wire, but it's not as optimal as 22 gauge wire because it's more likely to break, and especially if you have a lot of moving parts like a scissor linkage or a really complicated outtake, your wires are gonna break if you have thin wire.
Yeah.
And we also soldered all of our connections, which was fine. It would last for 2 months, like a couple months basically.
Yeah.
So we were fine all through welds, but after welds we had some issues
with wiring. Yeah, the solder was cracking and stuff.
So if you are going to solder your robot, do it intentionally and know that there's going to be
do it in places that don't undergo stress
at all, like no movement.
Yeah, if there's movement, it accelerates the process significantly.
And know that you're going to run out of time eventually.
Yeah. Another challenge we faced was we had this German exchange student. His name was Luca. He might be watching now, I don't know. But he was a big pain to manage, and sometimes team management skills, it's part of life. Sometimes you have to build that up as well.
He's gone now though.
Yeah, he's back in Germany.
Okay. Josh Rice asks, what additional robot functions do you think are important this year other than the main scoring mechanism? For example, like a rake for the pixels or a door opening mechanism, etc.
Yeah, so I think a lot of teams, especially for early competitions, probably won't focus as much on the pixels, but rather focus on a hang or a plane because they're also really fun tasks and they're kind of cool. But we think if you do it the other way, so prioritize the pixels and then have the hang and the plane as things that you consider, but don't focus on, it's probably better, because if you think about where the points come from,
if you have a plane.
Yeah, it's really only 50 points for both of those things combined. But if you can effectively cycle the pixels in auto or teleop, then you could be looking at 200, 300 points just off that by yourself. So
I think a couple teams will have